This video is going to, I'm going to explain Theorem 10. Take a minute and copy down the theorem and press pause. When you're ready to go, press play again. There are 17 steps in this proof, and you'll notice the very last line of our proof is the theorem that we're trying to prove. One before this, we take off the for all y symbol, so the reason for statement 17 is PGU. And then again, before that, we would need the for all z off of it. And again, the reason for 16 is PGU 15. Now, at this point, I'm noticing that I have to prove a biconditional statement, and that really consists of two implied statements. So to prove an implied statement, we use deduction theorem. So I'm going to go back up to the top here, and we are going to prove that the set containing y equals the set containing z if it implies y equals z. So to do that, we start with the dishype, the hypothesis to be discharged, and that's the antecedent of our implied statement. Then, next, I remember that Theorem 9 says this: for all y is an element of the set containing y. And then we take off the universal quantifier so that I have y as an element of y. Now, what's nice about this is that I know that the set containing y equals the set containing z. So I'm able to make a substitution here using statement 1. So I use the substitution axiom of equality with formula 1. That's what I'm going to use to make my substitution. And I'm substituting into formula 3 here. Now, that's going to be helpful because I know the definition of a roster name. The set containing z equals the set containing x such that x equals z. And then I'm able to make a substitution again using statement 5. So rather than writing the set containing z, I write the set containing x such that x equals z, so that I can then use the comprehension principle to say that y equals z. And now we are almost home free. So once I get the statement, notice it doesn't rely on anything because it's a statement that stands all by itself. I take off the for all y symbols using IU. And now I have y as an element of the set x such that x equals z if and only if y equals z. And then through modus ponens for the biconditional, I'm able to get y equals z. So we started with our antecedent and we ended with our consequent, and therefore through deduction theorem, I know that this implied statement must be true. So we are going to disregard everything after this dishype, our hypothesis to be discharged, and I'm just going to write something in here. It's not just formula 1 that we're discharging. We're discharging formula 1 through formula 9, because anything that we said after 1 really was not valid. It all relied on the fact that we are assuming something to be true, whether or not that is the case. Now, we've proved one direction of our implied statement. The next thing we need to do is prove the other direction. So we start with y equals z this time, and we are going to finish with the set containing y equals the set containing z. And actually, that is the easier direction to go, because if I start with y equals z through Theorem 4 or reflexive property of equality, I know the set containing y equals the set containing y. Then I'm able to make a substitution for y into there, so I have the set containing y equals the set containing z, and now I'm home free. I know this implied statement must be true. Y equals z implies the set containing y equals the set containing z, and that's deduction theorem. And again, I need to discard everything I said after that dishype. So formula 11 through 13. So now I have both of those implied statements, so I'm able to write my biconditional statement. And the reason for that is conjunctive inference Remember that a biconditional statement is really an and statement. So using formula 10 and formula 14, I know that this biconditional works, conjunctive inference. And then one by one, we talked about this, we're adding these universal quantifiers, and there you have our proof. Now, take a look at, keep this in your logic binder. We will continue with it tomorrow, and I would like for you to work on your assignment. It's on my website. Have a nice day.